Good morning, good afternoon to everyone. Welcome to this fifth module of the biotechnology course we are organizing together between Obreal and the Federal University of Agriculture in Nigeria. It's a real pleasure to be with all of you who are following through all our modules, hoping it's being useful for you to understand the basic concepts of biotechnology and how this can improve our agriculture, our food security, with a special focus on small farmers. In this fifth module, we will be devoted to biotechnology applied to food production. So this module is designed to explore the various applications of biotechnology in the food production and processing sectors, including the development of nutraceuticals. And we will do this together with two experts from Latin America and from Africa, following our interregional perspective. Fernanda Silva is joining us as co-founder and scientific leader of Biotechnology, a company that replaces the petrochemical solvents involved in industrial processes that have historically been dominated with, the petrochemical process that have dominated and will now be replaced by nature-borne alternatives by manufacturing green eutectic solvents. Their products are based primarily on biosourced ingredients, natural acids, amino acids, alcohol, sugars. With their technologies, liquids can be obtained when all compounds are individually solid. She has a strong background in research and teaching, former superior researcher at CONICET and professor in the Department of Biomathematics and Physical Chemistry at the Faculty of Agrarian Science at Cuyo University in Argentina. Thank you, Fernanda, for being today with us. And from Nigeria, Professor Obadina Ayehole, you know him. He's also the co-coordinator of this course. Thank you, Professor, for being here today with us. He is Professor of Food Safety and Biotechnology, former Director of Biotechnology Center and Head of Department, Food Science and Technology at Federal University of Agriculture in Nigeria, visiting professor, Department of Biotechnology and Food Technology at Johannesburg University in South Africa, and a former member of the Board of Directors, the International Union of Food Science and Technology. So two very distinguished professors, researchers, and entrepreneurs. We will all be very happy to learn with you. We have already a nice audience that are connecting themselves from many different parts of the world. I remind you the chat is open for questions in the frequent and questions and answers, or also in the chat. We will have some time at the end to ask the experts your questions. So thank you again, and Professor Obadina, the floor is yours.
Thank you. Today, I'm going to talk, or I'm going to give a lecture on title, The Impact of Biotechnology on the Food Industry. So I'm going to talk generally about the impact of this technology on the food industries, why Maria will be trying to tell us about a lot of things that this technology has been used to achieve. So my presentation will follow this format. Of course, biotechnology is a wide field. I'm going to narrow it down to what we all know, or what we're trying to do here, which is majorly on food. I will give us a brief definition of what food biotechnology is. I will try to also briefly talk about the historical context of food biotechnology. I will also try to say little things on the benefits of biotechnology to the food industry. There's also a lot of debate globally on the challenges and controversies surrounding food biotechnology. I will also try to mention a few of these. And lastly, give us few case studies about the application of biotechnology in the food industries. So join me as I go with my presentation. In a brief way, biotechnology can be defined to involve the use of living organisms or the system of making use of living organisms to develop or create products, meaning that biotechnology can be applied to various fields, but particularly biotechnology can be used in agriculture, in food production, and in medicine. It goes beyond these few fields that I've mentioned. But our focus here today is the scope of biotechnology in food industry. So I'm going to focus majorly on food industry. So when we talk about biotechnology or food biotechnology, how does it start? So there's some historical context about food biotechnology. As I said earlier, that biotechnology involved the use of microorganisms or the systems. So there are two distinct classics of biotechnology. We have what we call traditional biotechnology. And when we talk about traditional biotechnology, we are talking about fermentation. And fermentation is the use of microorganisms to convert raw materials into food product of interest. And fermentation or food fermentation has been since the creation of the world. We have so many products, food products, obtained as a result of fermentation. We have bread, which is fermented flour, in which microorganism, especially yeast, is being used in the fermentation of flour to give us a desired product, bread. When we also talk about bread, we also have some bread that are majorly being produced or processed using bacteria, not even yeast. Okay, they use bacteria, especially lactic acid bacteria, and such bread are known as sourdough bread. So these are products of biotechnology, but traditional biotechnology. We have beer, which is an alcoholic beverage, alcoholic drink that's so popular globally. This is also a product of traditional biotechnology because we use microorganisms to produce this. Cheese is also there. Cheese is the fermentation of milk to give a desired product called cheese. But in this case, instead of using yeast or bacteria, mold is the one that is doing the fantastic job to give us cheese that every one of us love taking. We apply it in most of our food products. Wine is another product that is being obtained from traditional biotechnology, fermentation of grapes. So wine is a fermented grape product that is being brought to life as a result of yeast and bacterial fermentation. So that is about traditional biotechnology. Now, we also have what we call modern biotechnology. Modern biotechnology. This is advanced stage of traditional biotechnology, where the microorganisms that are involved in the traditional biotechnology are later being worked on by obtaining the DNA, the genetic, the DNA from these microorganisms are being obtained and worked upon to give what is expected. There's what we call genetic engineering. Genetic engineering has been used as a biotechnology tools to produce products of desirable interest. We have GMO tomatoes, as you see on the slide, GMO tomatoes. These are tomatoes that has been produced with a trait of preventing infestation from insects. Okay, so nowadays, people are running away from the use of chemicals. So people do not want to apply insecticide again to their farm because of the adverse effect of chemicals on this food. And insects are always there to attack the food products. So we have GM tomato that has been designed, to resist the insect attack. So we have GM tomatoes. We also have beans that we call BT beans. So these beans, we also have this in Nigeria. It has been released in Nigeria, these biotechnology beans that can also resist infestation of pests on the tomato, on the beans. We also have some products that are also probiotic products. Probiotic products are products that are designed specifically using the microorganism that can make them to be nutraceuticals. Nutraceuticals, these are food products that can also serve as medicine. So they have the trait that when they are being consumed, they can act or they can assist to reduce the effect of pathogens on the system in causing some diseases or diarrhea. So we have probiotic yogurt, we have probiotic milk in that aspect. So all these are products of modern biotechnology. We have a lot, but because of the time, so I will limit myself with this. Another thing is benefit of using biotechnology in the food industry. On the slide, you will see very funny pictures of chicken. These are featherless chicken. I saw this chicken when I visited Israel, Jerusalem, to be specific, Hebrew University of Jerusalem. These featherless chicken are developed by scientists there. And what they have done is to knock out the gene responsible for feather production in the chicken. And when I asked the question, why the interest in knocking down the feathers? So the head of the team made me to realize that more of the feed fed to the chicken are used to produce feathers instead of the beef, the meat needed in the chicken. So this is also a benefit of using biotechnology tools in food production. Biotechnology in food industries have been able to enhance nutritional quality of food. Biotechnology tools have been used to improve vitamins and minerals in food, and this has resulted to contribution of improving consumer health. Biotechnology tools has also been used to improve the protein quality of food and fatty acid profiles of some selected food. And as we said earlier, that biotechnology is the use of the microorganism, but all these are being achieved through the modern biotechnology, where the DNA of particular traits of the food are being modified through what we call genetically modification, or GM. When we talk about preservation, biotechnology tools has also been used to extend the shelf life of food products. Both traditional and modern biotechnology methods have been able to achieve this. For example, through traditional biotechnology method, fermentation, it's possible to get a particular microorganism, for example, lactic acid bacteria, and use it to ferment a particular product in order to extend the shelf life of that product and getting another product from that raw material. In Africa, we consume a lot of fermented food from maize. And this product, because of the fermentation of maize, we can get this product to stay longer. Another example that is general and global is milk. A raw milk cannot stay more than 1 day, except you subject it to low conditions of preservation. But you can convert the raw milk to yogurt by fermentation using a specific microorganism. You can convert the milk to cheese by using a specific microorganism. When this is done, you are sure that you're going to extend the shelf life of that product in which the milk cannot ordinarily stayed for. So we also talk about flavor enhancements. Biotechnology tools have also helped in enhancing flavors in food. When microorganisms are used as a fermentation tool, as biotechnology tool on products, it degrades the substrates. No matter what the substrate is, either it's carbohydrate source or proteinous source or fatty source, that particular microorganism will degrade that substrate, break it down, and produce some metabolites. So among the metabolites are organic acids and flavonoids that give that product the particular, unique, and distinct flavor that make the product more acceptable to consumers. These are fantastic job that microorganisms is doing, that biotechnology tools are doing in food industries. What about food safety? Globally, food safety is a challenge now. People are having a lot of challenge about the type of food that they consume and the safety of this food. And it has been taking a lot of time. I mean, the time to check for the safety of the food is more now, about 3-4 days. You do the normal microbiological test to be able to identify the pathogens that is making the food to be unsafe. But biotechnology tools has been used these days to discover, to be able to identify the pathogens within a day, within few hours, using what we call biosensor. Okay, so this is part of the advantage and the importance and benefit of biotechnology in the food industry. What about the environment? Biotechnology has also been able to help, and I think Maria is going to talk more on that, in the use of the waste from food that will have been disturbed the environment become pollutants. So the biotechnology tools have been used to degrade these waste, biological waste, to get other important resources from that. Biotechnology tools is doing a lot in the food industries. But I will quickly go through the challenges. I have limited time now. Now, challenges. A lot of people have these concerns about PM food. Are they safe for consumption? What is the future implication of this? But these are being addressed. There are a lot of what do I call it? A lot of debate, a lot of enlightenment programs going on about this. Policies and standards are also being developed for biotechnology developed products, and also labeling. So these products are being labeled, so people know that this is GM food, this is biotechnology code developed product. So you have the choice to go for that or to go for organic or natural food products. Okay, I have 5 minutes. So public perception. So there are a lot of public perception about trust in biotechnology. But a lot of people are skeptical about the impact of GM food, but all these are being addressed through, as I said, a lot of debate, a lot of enlightenment program. It's going like what we are doing today is part of it. What are the success stories of this? This picture that I show is from my own university, part of biotechnology. In our center, we have tissue culture unit where we have been able to multiply banana plantain suckers. Okay, so this has been able to give us products that are drought resistant, product that's going to give you the same type of quality of banana or plantain, the same yield. So you are sure of what you are getting depending on your interest. So this is one of the success story. The yield is also being improved. You are getting a good quality of what you're looking for. As I said, food safety, people have been able to come up with seed, with crops that are resistant to fungi that will have resulted to mycotoxins challenge in seed. I've talked about the traceability using DNA barcode as means of detecting the safety of the product. We also have biotechnology products. We have this, in this picture, you see an apple, okay, but inside is orange, but it looks like apple from outside, but what you have inside is orange. Biotechnology has also assisted in improving the livestock. I've mentioned about the featherless chicken. Sensory attributes of product has also been improved through fermentation. Flavor has also been improved. So thank you because of the time. Thank you.
Thank you, Professor. It's been really interesting to learn from you the different uses, the different challenges, and these case studies or good examples that you have in your own lab or in your own university developed. So thank you for this. Thank you, the audience, which is very willing to learn and chatting, telling us where they are joining us from South Africa, from Cameroon, from Cote d'Ivoire. I know some others from Peru, from Argentina, so thank you all. And we will complement Professor Obadina's great presentation with Fernanda Silva's one. Please, Fernanda, thank you for being here, and the floor is yours.
Thank you very much, Jimena. Thank you, Obriel. It's a pleasure and an honor to talk to you. And thank you, Professor Obadina, for your your excellent presentation. My presentation is going to be a little disruptive because it is the widest biotechnology that you can imagine, yes, because it is not traditional. I will not talk about how living organisms can be applied in the food industry, but how solvents from bio sources can enhance in many aspects food. And as you know, solvents are everywhere, and especially in food. Solvents are, we eat them every day, all the time. We also smell them and absorb them, and they are used in the food industry as a key component for flavor enhancement, for extraction, for additives, for preserving all the food that you can imagine, and all everything we drink. And okay, I'm not able to move my. Okay, well, what has inspired us from the last 35 years is to become green. And these are the principles of green analytical chemistry that are, of course, aligned with green chemistry. I will not talk about each one of the principles of green analytical chemistry that are absolutely aligned with the ODS principles and green chemistry principles. But I just want to highlight that the factor that most impact on the greenness of a chemical procedure is for far or by far solvents. That's why humanity has been trying to replace the traditional petrochemical solvents forever. And we are absolutely sure that now we do have that green solvent. That's why we have been researching for a long time, and that's why we founded Biotechnology. If you want to claim that you are green, you have to objectively say that you are green. So you have to use metrics to demonstrate that. We like these metrics a lot. This is a agree methodology, and they are based on the 12 principles of green analytical chemistry. You can evaluate each one of the principles, and in the middle, you can have like the average of greenness of a methodology. So you can compare in terms of greenness and safety for the environment and for the worker. Each one of the principles of green analytical chemistry are based on diverse physical and chemical metrics, and this is just to show you which is how do we obtain that numbers and that colors to say that we are green. Well, this is the market for solvents nowadays. For the entire life of our humanity, we have been using traditional petrochemical solvents that, as you may know, that they are not from a natural origin, their raw materials are risky, they are high toxic, and they generate a lot of waste. Then biosolvents came to the scenario, and the only thing that changed is that the raw materials are from natural origin, but as you may know, the molecules are exactly the same, so we produce the same waste, and they are as risky as traditional solvents. Afterwards, ionic liquids became to the scenario, and we say, okay, that's the solution, but as you may know, they are not so safe, and they are really very, very expensive, so it's not possible to produce them in an industrial scale. So what we do is we try to get a greener solution and avoid the exposure of millions of workers to hazardous waste by using zero petroleum in our products, and of course without generating any waste to the environment. How do we do this? And this is why we are called a biotechnology company. We combine biomimetics in the way that plants produce their own solvents with eutectic technology. And that's how we produce our eutectic solvents. Eutectic solvents have been, sorry for the Spanish, I didn't see that, sorry. Eutectic solvents come from the Greek word easy fusion, yes? And as Jimenez says, when you mix two solids, for instance, if you mix urea and chlorine chloride, that their melting point is 300 and 133 Celsius degrees, when you mix them in proper molar ratios and proper conditions, this mixture of solids becomes a liquid. And this liquid has a much lower melting point, and it is a very, very stable liquid that can have many applications, especially in the food industry area. If the components of that eutectic solvent are natural, they are called deep eutectic solvents, natural deep eutectic solvents, and what is really amazing is that they are part of all the cells. It has been proven that it is one of the third cellular medium, and you can explain many processes of metabolic processes that cannot be explained in water on a hydrophobic medium. This is how it works when you mix two solids. Yes, you should find this eutectic point in which you find the lowest temperature of in which this mixture becomes a liquid, and it differs a lot from the theoretical eutectic points out. That's why they are called deep eutectic solvents. When both of the components of this solvent are from food grade, yes, they can be applied in the food industry for many purposes, as solvents or even as ingredients. Why is that? Because they are not only solvents, but they can also preserve your food. One application that we have developed in the research group is we could extract curcuminoids directly from curcuma powder, and in one single step we prepare the eutectic solvent and we extract the curcuma, and we were really surprised that the solvent is fluorescent, yes? Although the raw materials that we use, that in this case are fructose, one of the components, it does not fluorescent. So it can be also used for analytical purpose, yes? And another interesting application, is that it can take a lot of time to design and characterize a solvent. That's why we have developed an artificial intelligence platform to develop, design, and predict the physical-chemical characteristics of our solvents. So far, it is an internal tool, but in the near future, we are planning to share that with the society. And as I told you before, these solvents are not only solvents, but they can also act as antimicrobial, antioxidant, and you can also use to enhance the flavor of a food. Another example is to monitor the safety of several products. With the aid of these solvents, we can determine when food has been contaminated with fungus, And by the aid of these solvents, with a very simple methodology, we are able to determine the safety of the food. And this is something that Professor Obadina recently mentioned. With the aid of these solvents, we can develop a bioactive coating that is food grade to for post-harvest control. Yes, in this case was this film, this coating was made with natural dipeptidic solvents and a plant from Andes that has been traditionally used for medicinal purposes. Another very interesting project that we are developing is that we are performing a product based on yerba mate using our solvents that is excellent as anti-cancer food, really good. Yes, I can share with you all the information afterwards. I know we don't have time. This is some of the products we have already developed and are ready to be offered to our customers. And something that is very disruptive that we have developed that with a company in Mendoza, Argentina, which is called the Vinsa. They produce a seed oil from grape, and normally they use hexane. That's, as you know, hexane is not very safe. And what we do is that we want to replace hexane and also replace the pressing method to prepare premium seed oils. And in this case, what we use is a hydrophilic solvent, and this is made at a laboratory scale. And by using this hydrophilic solvent, just by centrifugating, you can see at the upper part of the system the oil, the seed oil that can be directly used for food and also for cosmetic purposes. And as you can see, we have much higher yield than the pressing procedure. Metrics, as you can see, just by changing the solvents, you can see how the greenness of the procedure is much higher. Another very interesting application of these solvents are to isolate plant proteins. I think that you are aware that to extract plant proteins, normally the industry uses sulfuric acid and sodium hydroxide. If a vegan knows that, he would never eat plant-based proteins. But yes, it is the solvents that are used to produce plant proteins. And we have replaced sulfuric acid and sodium hydroxide with the same yields by food-grade products, and also the quality of the final protein is much better because we are not using sodium and because our product contains an amino acid. So the quality of the final plant protein is much better. This is the greenness of the methodology compared to the traditional ones. You can see we're almost perfect. 100% would be the greenest possibility for that proposition. And this is also a very interesting application in which we use our solvents to extract lycopene from the food waste from the tomato industry. As you know, lycopene is very interesting, not only used as a colorant, but also used as a food additive. And as you may know, the most active isomer is the cis one. Yes, in this case, we are also comparing with hexane, and we have not only much more yields, but as you can see, our solvents can extract preferably the cis isomer, which is very important for biodegradability and the compatibility with human beings. This is our perfect extraction methodology, as you can see, completely green. And also, as I claimed at the beginning, they can be used as preservants. In this case, we have developed some products that can prevent, especially in bakery, from the production of these microorganisms. I don't know if I have been too long or too short, but okay, that's all I wanted to tell you. Just a quick glance of what can we do, and just to make you think that biotechnology is not the traditional biotechnology that we used to think. For the production of our raw materials, we know because we buy the raw materials, but raw materials that we use are also produced by biotechnology in the traditional way of biotechnology. And we also want to be called a biotechnology company because we mimic the way that plants produce their own solvents. So thank you very much.
Thank you very much, Fernanda. It's been a pleasure to learn from your company and how you have applied all your research abilities to solve concrete problems and contribute to the industry. This is like the whole idea of doing this among universities, research centers, and companies to understand the connections and to motivate. And you can definitely inspire the people that are here to connect demand and offered and capabilities and challenges. So we have some questions here. Teresa Cerón is asking, in terms of cost, how possible is to use this technology in the food industry, if it will increase production costs, or if you see some possible decreasing trend on cost due to this technology?
Well, that's an excellent question. Of course, it's key for the application of these products. We are cost effective, and the idea is that to be more cost effective with time. Some of the applications, the cost is absolutely comparable with the traditional ones. In the case of proteins, no, because as you may know, sodium hydroxide and sulfuric acid are extremely cheap. Yes. So in the case of proteins, the nowadays application should be for premium products, but we are confident that not only customers but also governments will be aware of the risk of using petrochemicals. So in Europe is definitely a tendency, and this is arriving just tomorrow. And in the rest of the world, of course, regulations will help to adopt greener technologies for sure. But yes, we are cost effective, and we are working very hard to do so.
Thank you. Thank you, Fernanda. Maybe I have one more question, and then we will turn to Professor Obadina. Have you assessed, and this has been a question during the whole course on biotechnology, about the safety risks? If you have assessed this on the solvents, even if you've explained there are natural solvents, but is there an assessment of those risks that you've done?
Yes, this is also an excellent question. When you say it's food grade, notice it's not only completely safe, yes? And also you have to reach the safety of the final products, because although there is no chemical reaction in the production of our products, the molecular entity is somehow different, yes? So we do perform toxicity tests, and the first, we do theoretical toxicity tests, then we perform in vitro and also in vivo cytotoxic tests, yes? And we also monitor the biodegradability of our products, yes? We compare that with the raw materials we use, but also we test the biodegradability of our products. In plants, in microorganisms, and in food, sorry, in water organisms, also in instruments, yes. So far, the results are excellent, yes, although there are a few raw materials, especially in the area of cosmetics, that we need to avoid.
Okay,
Also,
okay.
I have to say that the flash point and the vapor pressure, the flash point are very high, and the vapor pressure is very low, so they are really safe.
Thank you, Fernanda. I will continue with this question on solvents and then change to Professor that we can follow the line. Daisy is asking, do these solvents help in removal of unwanted components in oil, such as stronger odors, for example?
Yes, we have an excellent audience because it's also a very smart question. Yes, the solvents are designed at the molecular level. So it is also a good strategy to get rid of the things you don't want to extract from the plant. For instance, in the case of the biocoating I showed you, these are made by harilla. And harilla, as you know, it has a toxic component when it is at higher concentrations. So we do use chemometrics to design our solvents to get rid of the things we do not want to extract from the plant. Yes, this is possible. And in this case, it's another added function of our products because, as you know, petrochemical solvents extract a family of compounds in general, depending on their polarity.
Thank you very much. And going back to Professor Badina and your case studies with the selection and these varieties drought resistant, let me ask you, and also connecting to the overall objective of the course, which tends to understand the potential of biotechnology for small farmers and for food security, if you can go in depth on this issue to tell us if this technology is really available for small farmers, if you see some challenges there, what should be done in this so that not only big companies and big producers can profit from this technology, but also small farmers that we know account for more than 40% of global food production. Can you tell us something about this, Professor?
Yeah, thank you, the moderator. The biotechnology application in the food industry, especially in Africa and most of the low medium income countries, it has become something that have come to stay. The small farmers have benefited from it. And to also say that this is the way to go. As I said, in terms of yield for the farmers, there are a lot of issues now about climate change as affects agriculture and yield. So we have a lot of varieties that are developed using biotechnology tools like seed, like planting materials that are resistant to infestation by insects. For example, we have maize seed, we have cotton seed, we have soybean that has been developed using biotechnology tools that are resistant to insect infestation that will have reduced the yield of these products. We also have disease resistance crop that has also been developed. We have sweet potato. We also have some products for cassava that are disease resistance. As I said, in Nigeria, we also have improved variety of products like sorghum that nutritional content has been improved. In my own university, we also been able to come up with suckers for planting that we've been able to say, okay, this particular sucker, plantain sucker, will give you this particular yield of plantain and its resistance to the disease around. And you'll also be able to get your desired output in terms of yield, in terms of the properties of how you want the plantain to look like, in terms of how tall do you want the plantain tree to be. So all these are advantages that farmers have been able to enjoy, and they will continue to enjoy from the use of modern biotechnology tools. But personally, I have a challenge, and that is what I've been trying to do in my research. And if I'm able to get it successfully, I'll be more fulfilled. Many of our fermented products in Africa and low developed income countries are still undergoing crude method. When I say crude method, we use spontaneous fermentation process, whereby the microorganisms involved in the fermentation are just coming by chance. They are not controlled. For example, in yogurt, you have a particular selected trait of microorganisms that are used to ferment the milk, and you get the same results anywhere in the world that you are producing your yogurt, in as much you use the starter culture. But many of our fermented products in low developing country, for example, cassava, maize, are still fermented without using controlled microorganisms. So the product that we obtain from this are not, in most of the time, the quality are not the same. They have safety challenge because you cannot control other microorganisms that are not wanted from the environment, from getting into the fermenting vat. So I look forward to a day when we're going to have our own starter culture, microorganism of expected strain that we can introduce into our cassava, and it's going to ferment it within limited time, and it's going to give us the same quality of product from cassava, the same quality of product from maize, the same quality of product from sorghum. Okay, so these are things that I think if we are able to do, the farmers, the small, medium enterprises in low, middle income country will be happy that they are able to use this technology of biotechnology. Thank you.
Thank you, Professor, for your question. And we are almost running out of time, but I would like to connect one comment and one person that we have on our room today. His name is Atsekambo Marshall. He is General Coordinator of the Pan-African Think Do African Network of Young Researchers. So as you both professors have been and are researchers, but have connected to the private and productive sector, I would like to ask you to motivate, inspire, and maybe tell him and all the audience some advice on how to connect these two words. And as I mentioned, we have a question on that, or a comment on how to understand which is the opportunity when one have a land, a piece of land, what to produce and how to sell. So if you please can give a general comment on opportunities, challenges around the world in the food industry and research and biotechnology, how to connect them both to have profitable and sustainable projects. Fernanda, if you want to come in.
Yeah, it is definitely something we must do, and we should do that right now. Yes, so far, the time that we spend from science, the typical manuscript papers to be transferred to the society and to be adopted, that technology is too long, and humanity cannot wait that. So I strongly encourage young people to do that in a very effective and I would say invasive, in the good way of invasive way. We have to push hard to do that, and to the humanity. We invest a lot of money on research, which is excellent, of course, and I completely agree with that. But this is the step we need to do, and we need to do it quickly. Yeah, the frontier of knowledge should be immediately adopted by society. And I think this is changing. This is not easy. It needs effort not only from the academy but also from the industry. Some industries are willing to innovate. For instance, the cosmetic industry is really uh, is all the time innovating. Yes, because of the customers maybe also that are pushing that. In the case of food, this should be done much faster. It is possible, yes, but we have to work together. Yeah, academy, industry, and consumers.
Thank you, Fer. Maybe Professor Badina, if you want to complement, and we are almost done since we are running out of time.
Okay, in a quick one, just to say that there are a lot of opportunities in the food industry where biotechnology tools can be applied. I want to encourage the youth to embrace the technology. And how do they do that? They need to develop interest in biotechnology, full biotechnology as a course. Because once they do that, they'll be able to identify these opportunities, because we have gaps, a lot of gaps in the food processing chain where biotechnology can assist to fill. So with that, I will stop. Thank you.
Thank you. Thank you so much, Professor Badina, and thank you, Fernanda. A big applause from all the audience. I'm sure we have all really enjoyed learning with you. It has been challenging, and all your material, this video will be uploaded on the training platform so that all the participants can profit and learn from it. Then, as usual, you will have a small test to check on the knowledge and skills you have gained. We will see each other next Thursday for the last module of the course, which deals with biotechnology and the management of agricultural waste. So we look forward to have you here. We will enjoy a presentation from Universidad Agraria La Molina in Peru and a case study from a company in Argentina working with agricultural waste. So that will be our final module that will integrate the concepts we have tried to address during this course. So thank you again, Fernanda, Professor Badina, and all the audience that have joined us. We will show you a little video now of an activity really interesting we are doing in Ethiopia next July. You are all invited to join. There are interregional dialogue policies that contribute to put these biotechnology issues on the table to get action and will from the different stakeholders so that we can push together forward to address our global challenges.
The second interregional dialogue on education and development in Africa, Latin America, and the Caribbean will be held in Addis Ababa, Ethiopia in July this year in the headquarters of the African Union Commission. This is an event that is co-organized by OBRAL, the African Union Commission, the government of the Federative Republic of Brazil through its Ministry of Education and CAPES, with the support of the African Association of Universities and the Latin American and the Caribbean higher education space. This event will consist of 3 days of work. The first day will be devoted to political dialogue between political authorities and national authorities and regional and continental organizations. And the second and third day will be devoted to the academic and scientific dialogue on priorities and thematic areas that are strategic for the development of both regions, such as digitalization, data, recognition, higher education as a vehicle for development and for regional and continental integration. This all started at the Transforming Education Pre-Summit that was held in Paris in 2022. That is when the former head of Education Division of the African Union Commission and the former Ministry of Education of Argentina, who was exercising the presidency of CELAC, gathered for the first time and discussed the possibility of having an inter-regional dialogue on higher education and development within both regions. That led us to the first event in Barcelona in November 2022 with the support of OBRAL as a strategic partner for CELAC and for the African Union Commission on higher education. That led also after that to the first inter-regional dialogue that was held in Argentina in March 2023, and to another event that was held in Namibia, where many rectors and many authorities from Latin American and the Caribbean associations of universities gathered with their African counterparts to keep following up and deepening this dialogue. This is absolutely key for OBRAL. This interregional dialogue materializes our unique perspective regarding interregional cooperation in the higher education sector. Our vision that there are many Souths and many Norths that are diverse, but that share common problems and common challenges that require shared solutions. It also constitutes a platform to pass an essential message that empowered universities and higher education institutions are key agents of development and are crucial and essential for the interregional, regional, and continental integration processes.
Thank you. Hope to see you there and see you next Thursday for our last module. Thank you, Fernanda, Novadina, and all our audience.
Thank you, everyone. Thank you. Bye.
Nice day.
Bye.
Bye-bye.